Hello and welcome to Beamer, folks. And now, numbers relevant to my project, my barometer project. Before you is a list of numbers that are the principal numbers relevant to the project. At the top of the list is 16-bit D to A conversion representing full-scale deflection. Well, that is the full scope of 16 bits, which is 65,535. I don't know whether I mentioned it before, but I tried the intrinsic 8-bit wide D to A conversion for this barometer, but I found the resolution just not sensitive enough for this particular need. It does need 16-bit resolution. The next number down is fairly obvious. It's half the above. It is important to this project, and of course, naturally, it is 32,767.5. The third item down on the list is normal average sea level atmospheric pressure. For my part of the world, which is in Torquay, UK, this represents 101,325 pascals. I don't know about other parts of the world. I assume it to be the same, but that's what it is here. The fourth item down, number down, is atmospheric drop per 30 feet above sea level. Well, the further you climb up away from the sea level, the atmospheric pressure will go down. It's a natural law, and it goes down at approximately the rate of 100 pascals per 30 feet. I live 330 feet above sea level, so that would translate into 1,100 pascals. The next relevant number down here, which is a fairly universal conversion here, and that is pascals to inches mercury conversion. That's the HGIN conversion, and what you do there is you plug in the number of pascals that you've got into there and divide it by 3,386.4. I will get the calculator up. Okay, I've pulled up the calculator, and what I will do is work out the my home altitude above sea level, normal average sea level atmospheric pressure. So let's put in that normal pressure into the box here. So it's 101,325,325, and take away from that, because whenever you climb up in altitude, the barometric pressure goes down. So let's put in 1100, and what does that equal? It equals 100,225. That is what the atmospheric normal average atmospheric pressure will be reading where I live when the sea level is at 101,325 pascals. So that's that. The next item, and incidentally, that has to, when I get that reading where I live, my analog meter must be in a reference position to 2.5 milliamps, but I'll come to that in a second. The next item down on the list is just the simple Pascal to inches mercury conversion. So if I were to take that number there and divide it by, so you just got to plug your pascals into that part there and divide it by 3,386.4. So let's do that. Let's put in 3,386.4 and see what that equals. And there we are. Now that is in inches Mercury. So therefore, that's the reading of 29.59, which is just under 30 inches, of course. Let me do it for the actual sea level one. So let me go, rather than where I live, let's go there, and then which is the normal average sea level barometric pressure. And let's divide that by 3386.4. And what is that equal? Right, 29.92. So if you were to have the barometric device at sea level, and you had it conditioned to read inches Mercury, it would, instead of reading the 101,325, it would read 29.92 inches Mercury, just under the 30 inches. We tend to think of it as 30 inches, but actually the normal average sea level barometric pressure is just slightly under 30 inches. Okay, so let me drop that down there and go on to the next item, which is the okay. So if you take the 16-bit wide number up here, which is 65,535, it's a 5 milliamp analog FSD meter. So if you divide that by 5 to get what the number will be for every milliamp of movement on the meter, you'll come to a number which is 13,107. So therefore, going down to second but last of these numbers, so therefore a 2.5 milliamp position on the analog meter, which is my reference position, you would then take that number of 13,107 and multiply it by 2.5, which comes to this number here, which is 32,767.5, which is exactly, as we stated on the second point here, the natural half 16-bit wide number. So that all makes sense, doesn't it? Hopefully, anyway. The final item on the list is direct conversion from pascals to a 16-bit meter value. Well, let's try that. Let's bring up this calculator again, and what have we got? Let's go back to there and put in, which is the normal average atmospheric pressure, sea level, and divide that by 2.5837, or 2.5837, and what does that equal? And that equals 39,217. Well, if we were to divide that number by 13,000, which is the per million number, which is 13,107, it will come up to a analog meter number. So this is the number that is presented on my analog meter of 2.992. Again, just under the 30 inches Mercury number. So that confirms a list of numbers, that they're working correctly. There we are. That's the numbers. I now move on to software. This is Beamer signing out for now.